Alrighty, I just put 24 problems on the board. I'll try to get this done before our class starts at 9 o'clock. And then I'll do the second video later today. We have a new student who we will meet soon. And so she'll be joining us. And so I want to spend time trying to help her catch up. All right, so without further ado, you were asked to find 3 points on this. And so 7 makes a 0. 0 times anything is 0. So we can immediately see the pairing, 7, -4. And we have talked about the change in x. Let's use it. 12, 17. And the change in y, -7, -10. And you can always check any of these points in the equation. The only thing I'll add to this is not a graphing form that you will see in a textbook. What you'll see in a textbook is y plus 4 equals -3/5 x minus 7. That's called point slope form. And it has some benefits in terms of new axes, and I'm not going to get into that right now. But this reads better. So that's what we're doing. All right. Slope-intercept form, I believe, to get our fractions in order. So -3 times x, and then divide by 5. -3 times -7 is +21, and then divide by 5. And the number -4 is -20/5. Okay, we've talked about how to get like terms here, like division statements. So -3/5 x plus 1/5. Okay, now I'm talking to you. It's quite possible. Oh, don't come on. Don't come on. I'm doing a video of the test, the answer key. There we go. Nice, though. All right. So -3/5 x plus 1/5 is the, or Matt just joined us. That's all right. So this is slope-intercept form. And if I make a mistake on any math, because I'm talking to you and working at the same time, we'll catch it. Okay, but hopefully I won't do too many zingers here. All right, so what did I ask here? Write the equation of the line. All right, well, if we can go from an equation to the points, we should be able to go back. All right, so y equals -9 means that we have to get rid of it. And we want to change this unit into that unit of measurement. And subtraction will get rid of that unit of measurement. It's gone, and this unit of measurement comes in, like miles per hour. Hours in, miles come out. Okay, then when we drop a 1 in, we've got 10 new units. But if we divide those 10 units, like hours, out of the problem, we can bring in the new amount we want by adjusting the number 2 down 7 to get to -5. All right, so I like tabular versus parentheses. I like to change it in tabular. I just find that I make fewer mistakes while presenting it to you. All right, so I guess we're just solving an equation here. This is slope-intercept form. And so y-intercept to -16. I'm going down 2/5. So I've got something that looks like that for a linear function. And I'm trying to find a height of 12. A height of 12 is above y equals 0. And now I know my answer is negative. And, so it's a ways away. So let's find out what it is. So we add 12, 16, and that gets us 28. And textbook would say, what you do to one side, you do to the other, and multiply by the reciprocal. It's much easier just to say division by 5 becomes multiplication by 5. That's 140. Okay, and that's -2x. It's easier to do it in 2 steps. And so I usually like to not divide by negatives, but cut to the chase, -70. All right, and it's out here. Yeah. So this is 16 units, remember. I wrote 0, -16, right? So it's quite a ways out there. All right, next. Moving right along. Yep. So we got 2 lines here. One, just a quick little sketch here. Y-intercept, the 1 steeply going down at 12/1, -4, and going up at 3/1. All right, so it looks like I lost track of where I was. Looks like I'm in the 4th quadrant, so I should have a positive x value, and it looks like it might be pretty small. We'll find out. I'll bring the minus 12x to the other side, so that's 15x. I'll add 4 to this side. That's 5, and it looks like it's a 30. Yeah, it was it was in the prettier picture here. Boom, boom. Yeah, we can see that it's positive and it's small for x's. Just because it's a test, you want to make sure you're right. 6 minus 4, we've practiced this immensely. X squared minus 6x plus 9. Multiplication before addition of 6. There's no reason to put the plus sign here, but it's a positive 6, which means we're adding 6. So we might as well put it at the other side over here. So we got minus 4x squared, positive, negative times negative, positive 24x, negative 4 times 9 minus 36. And then the last thing we're going to do is add 6. So minus 4x squared plus 24x minus 30. All right, moving right along. Kind of put these on the board before things have to keep looking at the paper, trying to cut down on the time here a little bit. Let's get this one. Let's see. Nope, we're here. All right, so I noticed on the test that, and I'll mention this at 9. I don't know what happened to problem 7 and 8, but we're jumping to 9. And I can only imagine that you're putting this in graphing form. So the quickest way to put this in graphing form, I'll do just because I want to get a quick answer before I start talking about it. 2x, they're opposites, positive, negative, so it's negative. 216, 8 cut in half is 4. 4 squared gets me 16 times 2 is 32. That number isn't 32, so I'll get rid of it, and then I'll add the 5. And then you erase that or do it in your head, and you got minus 27. I got to get an eraser. I got to get an eraser. I should always get the eraser with me, but I didn't. Oh, well. It's hard to erase that. Minus 27. Now, how do I know to do that? Because in this equation, I can immediately set up, I put a 0 in, I get a 5. If I put a 0, I get a 5. All right, so I come back here, I put a 0 in. I don't get 5, I get 32. I don't want that number. It's another aspect of conversion. I want a 5. Okay, so that's the quickest way I found over the years to put that in graphic form. What I found students are more able to do at first correctly, and that's what you want a correct answer. And I think it's useful for you to do it actually this way for quite a while, because you want to keep reinforcing in your long-term memory that quadratics minus b over 2a is what's important. I'll do a quick square. X minus 5, x minus 5. Now, we said that the minimum of a quadratic happens at 0, and that's when you have 5, right? 5 minus 5 gets you 0. So if you were to square this, you get x squared minus 10x plus 25, right? Well, this is the linear term, this is the quadratic. So, and if I did x times x, there's the quadratic term. If I do x times minus 5, there's minus 5x, that's a linear term. And if I do minus 5 times x, I get a linear term here. And that's what we're talking about. We're talking about the first 2 terms of this minus b over 2a. Now put a 5 in. If we put a 5 in, this section of area is 25. Right, I'm going to drop a 5 here. And I'll drop a 5 here. Okay, so I'm multiplying this 5 times that 5 to get this. Now I'm going to multiply this 5 times that negative 5. That actually gets me minus 25. And then I'm going to do minus 5 times 5. That also gets me minus 25. So do you see the negative 50? So if you drop 5 in here, you get 50. All right. Oh, because I got a double x squared here. Okay, so I'm not actually showing the same quadratic over here. But I did show you x minus 5 times x minus 5, which is x squared minus 10x plus 25, right? So I was giving you a little look at why you get, in this instance, minus b over 2a gives you that drop of 5 in. There's your 25. There's your minus 50. And it's coming from all these geometric drawings. Okay, that's another layering of understanding, I hope. All right. I think this is a quadratic. So that's the vertex. If that's the vertex, we know we have a -7 to 11. It's going up. So I am going to draw U-shape up. I'm going to label this 3, -7. Hope you wrote x minus 3 squared minus 7. Now notice what we have over here. We don't have just x minus 3. We don't have a line. We have an area change. This is an area. Okay? And so when you drop 10 in, you don't get 7, you get 49. And 49 units of change doesn't take me to 11. What takes me to 11? 11 and 7, 18 units of change. Okay? So that's in 3, 10, 3, -7, 10, 11. 10, 11. So if I went over 7 units and squared, I should have gone up 49. I should have gone up way up here, 49 units, but no, I went up 18. So it's a fractional amount of change that I'm introducing to you here. All right, I think we're 10. Do I have something on this side? Yep, 11 and 12 on this side. Marching right along. All right, so here's a quadratic. What do I know? Cup shape up. I know it vertex 4, 7. I know I want a height of 25 in a table. I want to find out what numbers get me 25, and I know there's going to be a couple. There's going to be a positive side to this and a negative, or at least a right side answer and a left side answer. Okay? So how do I find it? Real easy. Subtract 7. 18, divide by 2. 9, remember to take the square root of 9 plus minus. So plus minus 3, and then add 4. Okay? There you go. So 4 plus 3 is 7. So one of my answers is 7. And the other answer is 4 minus 3, which is 1. So there's my right-hand answer. There's my left-hand answer. Anything else I want to say about that? So let's actually look where this 2 comes from. One more time. Useful. So over here we have an intersection at 725. Thank you. 725. All right, let's get this out of the way. All right, let's talk about how do you get you change in your x from 4 over to 7. That's 3 units of change. You're going to square that. So you go up 9. But from 7 to 25 is up 18. Well, how does 18 units compare to 9? It's twice. I need twice what should have happened. Okay, so this is an adjuster to make sure you go through the proper point that you want to go through as measured from the vertex. So really, 2 is rise over run squared. And that's how I want you to see this, run squared. Okay, operational change. Moving right along. All right, we've done this squaring. So let's hope if you have to do it like that, parentheses times parentheses, go right ahead. But 4 squared, 16, a to the 7th squared, a to the 14th, x squared squared, x to the 4th, minus 4 times 3 is minus 12, but you're going to get minus 12 in both places, so you got minus 24. Where am I? Minus 24. A7, because A7x squared is just a number, times y cubed, just a number. And how many of them do we have? This is counting how many we have. So A7 x squared y cubed plus 9 y cubed squared y to the 6th. Okay. All right, now we're doing a quick product. And there's only one way to get 5x squared, and that's 5x times 5x. We haven't got much choice. It's either a 1 or a 3 here. I said mix. Sorry, careless. 5x times x. There we go. Now, I put the numbers over here because whatever you think they are, they're actually going to get multiplied by 5 as well. So what gets us close to 14? Yeah, I hope your brain jumps to the number 3 real quick. And that's 1 unit away from 14 after I get the 15. And then I just have to make sure that the negative wins out, the bigger product. The bigger product is the 3 times 5. So that's the one that wins out because it's middle terms. All right, so we might hit something that you haven't done quite as much as those other problems right now. So I'm going to draw this. So y equals 3. This is what we did yesterday. Okay, I can see, okay, my amounts are going up as my time moves into the future. And so I've got exponential growth. And so I know that this is 2018, comma 9. And over here, I've got, I'll put that point there in a minute. So let's just say that in Gill, always in Gill, there have been at least 3 sheep. In the year 2018, there were 9. And 10 years later, there were 15. And the population of sheep is growing exponentially. We like sheep in Gill. We want more sheep. They look very pretty on the hillside. All right? So what I really want to know is, you know, there always been 3 and now there's 9. Well, I guess there's 6 more than there used to be. Or at least there always was over here back in, you know, prehistoric times. Okay, yeah. Kicking back historically. Timeline. We got a timeline here. Timeline. Yeah. All right. And so I guess I also want to know how many more there's going to be. And well, 3 to 15 is 12. Okay, now I know where I want to put this. I want to put that there because I can see I have a doubling function here. Okay, so how do I write the equation? Well, I know that I've always got more than 3, and I know the first jump is 6. The next jump isn't 6. No, the next jump was 12. Okay, now, yeah, obviously could write 2 here. I'm just going to leave it as is. And that dictates the amounts. There's an amount of sheep, there's an amount of sheep, there's an amount of sheep. Now, I bring my attention to time. So I'm going to change this from y to a of t. Functional notation, the amount of sheep based on time. So I'm going to put a t over here as my variable. Okay, my first year is 2018, so I want to get rid of that year and make it a 0 because I know anything to the 0 is 1. And 1 times 6 is 6 plus 3 is 9, so it checks that box. Okay, then I want 2 times 6, so I want this number to become the number 1, but I'm putting 2028 in there minus 2018. That's 10 years. That's not 1 year change. That's 10. So I'm going to divide 10 by 10. So that creates the number 1. And 2 to the 1 is 2 times 6 is 12 plus 3, 15. I hope you're following that. All right, I probably put something on this side. I didn't. Oh, could have put more problems on the board. All right, we got some quick skill work here. Some quick skill work. All right, so we got, yep, where am I? Can you see? Yeah, okay, I'm here. Everything's backwards on the screen. All right, so we have been introducing the 3 exponential operations, which are reciprocating, that's the minus sign, the 3 is cubing, and the 2 in this instance represents a square root. And it doesn't matter what order we do them in. So the square root of 25 is 5. 5 to the negative 3 is 5 cubed, 125 reciprocated. Okay, I trust I don't have to talk about that too much more. I got a feeling when I see the test, I'm hoping that I see a bunch of right answers. And if not, we'll pick it up again later. All right, 17. So, okay, we just talked about square rooting. So square rooting is coming into play here. So 25 is 5 squared, and we want to know to the what power will get me 5 to the 1. So we can see the same bases, therefore the exponential activity has to be the same, and x equals a half. In other words, the square root of 25 could have been written as 25 to the 1/2. Okay, here's your answer. That's what I want to see. That's the exponent put on top of 25 to get 5. That's what's in the parentheses. All right. All right. I say all right a lot of times, don't I? Good. We want all the problems right. That's why. All right. Negative 2. 81 is 9 squared. Okay. I can now see that this could have been written as 9 to the negative 2. And that's what you're really trying to do is you're trying to get all the exponential activity inside that parentheses, and then you're looking for what it is. Because this is really saying 9 to the x equals, in the parentheses, we have 9 to the negative 2. I think we've cracked the problem. So this one is 4 to the what equals 8. I hope you can do it in your head. I hope you can say, what do I have to do to a 4? Hope you say, oh, I got to take a square root and cube it. But it'll come out of doing this. What's the same base? Same base is 2. And so 2x equals 3. So that's 3/2. Okay? That's the exponent. That's the exponent you put on top of a 4 to get an 8. Remember what that is, square root. Square root of 4 is 2, and 2 cubed is 8, and that's what we were trying to produce. Moving right along, I feel like Monty Python movie. Now for something completely different. That's a little before your time. X plus 2 squared plus y minus 5. Oh, okay, I'm doing a little shortcut here. X plus 2 squared minus 4 plus, I'm going to put a big plus there because we're going after one of these relationships. And this is building us towards the study of trigonometry. And we're going to tackle some trig after the break, after midterm, maybe before. We'll see. Okay? But I want you getting off on the right foot when you do your pre-calc class. All right? And I'm telling you, I'm getting a lot of feedback from students coming back and going, I'm glad we did that. Okay? Because their classmates are struggling and they're doing fine. So we're going to do the unit circle, not memorize it. We're going to create it. We're going to see where it comes from. And it starts here. It starts with this concept of triangles in a circle. Okay? So let's remember that plus. Y minus 5 squared minus 25 equals 7. All right, so I move 29 units over there. That gets me x plus 2 squared plus y minus 5 squared equals 29 and 7, 36. 36, which is 6 squared. Okay, I'm going to leave all that there. So I'm not sure what I asked on this problem. I guess center and radius, but I think I asked range on one of these things. Center and radius. All right, we're good. All right, so I really have, I'm just going to write 6 squared here. Okay, there we go. Let's go to that. There's your a squared, b squared, c squared. There's your boom, 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 this area, and this area, right? And the sides are x plus 2 and y minus 5 and 6. And as one area gets bigger, the other's got to get smaller, and those coordinates start to interact. So the center, cut to the chase. Negative 2, 5. Radius is 6. Okay, there's the hand of the clock. Right, and there's the origin here. What gets rid of all of the area coming from the horizontal? Negative 2, which means everything's got to come from the vertical, which means I'm straight up at that point. All right, it's just another layer of discussion here. Almost done with the first video. I'll do the second one later today. I'll take a little break. Got my coffee. Let's see. Yeah, we're good. Good with the last problems. All right, we got F, we got G, 2 different calculations, distinguished by different letters. So I'm going to put 2 ninths into F. So minus 5 times 2 ninths plus 7. All right, so minus 5 times 2 minus 10 over 9 plus 7 has to be something over 9. So how do you figure out? Well, just multiply, 63. So I'm looking at this is equal to 53 over 9. And remember, you've learned something if it's easy. 22, f of g of negative 1. Let me get my eraser. F of g of negative 1. Just want to make sure again that you hear that this is the same thing as f of g of negative 1. You might see it that way on an SAT. Okay, open circle means this. Closed circle means you're multiplying the 2 functions. We'll do that at another time. All right, so I'm going to plug negative 1 into f and find out what I get. I'm going to do, g of negative 1, excuse me. So over here, g of negative 1. So I said that backwards before without looking. Did I say it right? No, I did say it right. Okay, so we're good. -1 cubed. -1 times -1 times -1 is -1. And then we're subtracting 4. So that's -2 minus 4. So now I know that g of -1 is -6. Yeah. So now I'm going to take f and throw -6 in there. -5 times -6 plus 7 is 30 plus 7. So we now know our answer is 37. All right. Probably need a little more room here. So let's go over further. All right. So we're looking at the inverse of g. Let's see. I think I can work this one up. So step 1 is to rewrite g of x as y equals, but I'm going to cut to the chase and switch the x's and the y's because I don't know if we're going to be able to see it moving up. 2y cubed minus 4. So that becomes subtraction of 4 on this side. 2y cubed, let me look at the camera, we're good. Then we're going to divide by 2. X plus 4 divided by 2 equals y cubed. Are we still good? We're still good. So I'm going to take the cube root of everything on the left side in the cube root. And that's my new function. So my inverse function is the cube root of x plus 4 over 2. So let's check our answers here. Let's put a 2 in. Let's put a 3 in. 3 cubed, 27, times 2, 54, minus 4 is 50. I think g of 3, if my brain isn't off, got me 50. I am a little tired right now. All right, if g of 3 gave me 50, then the inverse of 50 should get me back to 3. So let's put 50 in here. 50 plus 4, 54 divided by 2 is 27. And the cube root of 27 is 3. Okay, I'm feeling secure. Square root. All right, so I could have written 20 as 4 times 5. And I know what the square root of 4 is. It's 2. So that's gone. I know what the square root of b squared is. It's b. That's gone. I know what the square root of c to the 6 is. It's c to the 3. That's gone. And I know what the square root of d to the 18 is, and I'm going to put another d in here. I know the square root of d to the 18th is d to the 9th. And that's gone. Now I look back and I say, oh, 5a still here. Hi, 5a. And I guess it's d. Yeah, and I guess you could see that. All right, so that's part 1. I'll do part 2 later today. In between, I got a nice friend coming on Zoom at 2. And so I'll do it sometime between 12 and 1. All right, see you all shortly.